Here's another work problem. We're going to do number 5. Harley takes 6 hours to do a job that his father can do in 3 hours. The father's boss can do the job in 2 hours. How long does it take the 3 of them working together to do the job? Remember number 4, we had 2 people working. Now we have 3 people, but it's the same idea. So what we're going to do is we'll set up our table. And we'll try to find out their work rates. So Harley can take 6 hours to do the job. So every hour he does 1/6 of the job. So his work rate would be 1/6 per hour of the job. The father takes 3 hours, so his work rate would be 1/3 of the job per hour. So this is 1/6 of the job per hour. In 6 hours, he would do 6/6 of the whole job. In 3 hours, he would do the whole job. And then the boss, he does 1/2 of the job per hour because in 2 hours he could do the whole job. So his work rate would be 1/2 of the job per hour. And this is going to go into our table. How long does it take the 3 of them working together to do the job? So we're assuming that they're all starting at the same time. So they're all going to work the same amount. So the time they're working will be X. So we put our rates in. Harley's 1/6 per hour. Father is 1/3 per hour. And the boss is 1/2 per hour. And they're all going to work the same number of hours, so we'll call that X. That's what we're looking for, how long they're going to be working. And we multiply across. Rate times time equals the amount of the work done. And in X hours, Harley's going to do X/6 of the job. If he works 6 hours, he'd do 6/6 of the job, or the whole job. So this is the fractional part of the job done. Fractional part of the job done. In the X hours, that would be X/3 for the father, and the boss will do X/2. And all these fractional parts of the job will add up to be one whole job. Because these are all fractional parts, and if we want one whole job, they add up to be 1. So there's your equation. And that last column, X over 6 plus X over 3 plus X over 2 equals one whole job. All those fractional parts will add up to be 1. So, excuse me. So we want to get rid of these fractions, so we multiply every term by the LCD, and the LCD looks like it's going to be 6. Six over 6 is 1, so we just have X here. 3 goes into 6 twice, so we've got 2X. 2 goes into 6 3 times, so we've got 3X. And that adds up to be 6. So 1, 2, 3, 4, 5, 6. So 6X equals 6. So X equals 1. So 1 hour. Okay, that seems kind of curious. Let's check this out. In 1 hour, Harley would do 1/6 of the job. I guess I can write it over here just to check it. He would do 1/6 of the job. In 1 hour, the father would do 1/3 of the job. And in 1 hour, the boss would do 1/2 of the job. And if we put these all in as a common denominator of 6, this is 1/6. This would be the same thing as 2/6. And this would be the same thing as 3/6, right? And 1, 2, 3, 4, 5, 6. If we add those all up, what do we get? 6/6, or 1 job. So it does check out. Oops, you can see that over there. There we go. Again, in 1 hour, does 1/6 of the job, 1/3 of the job, 1/2 of the job, and if you put all those over a common denominator, add them up, you get 1 complete job. That worked out nicely.